Hello everyone, I'm Jiang. In this video, we'll talk about the atomic structures. Some property of materials depends on the atomic structures. Each atom consists of a small nucleus. The nucleus located at the center and volume is small. So it's small nucleus. And the electrons are moving around the nucleus. The nucleus is composed of protons and neutrons. Proton and neutrons. The neutrons is electrically neutral, but electrons and protons are charged. The electron is negative and the proton is positive. For an electrically neutral atom, the number of the electrons and protons is the same. So the number of the electrons is equal to the number of the protons. Protons and neutrons have approximately the same mass of proton and neutrons, which is significantly larger than that of electron, larger than the mass of an electron. But the number of protons and neutrons can be different. For a given element, the number of protons is the same for all atoms. But the number of the neutrons may be different. So the same element can have the same number of protons but may different number of neutrons. Here is an example, carbon-12 and carbon-14. Carbon-12 and carbon-14. Carbon-12 has 6 protons and 6 neutrons. Carbon-14 has 6 protons but 8 neutrons. These two are called isotopes. During the later part of the 19th century, it was realized that many phenomena involving electrons still could not be explained. What followed was the establishment of some principles and models. An early outgrowth was the Bohr model, in which electrons are assumed to revolve around the nucleus in discrete orbitals. So the orbitals are discrete. It also stipulates that the energies of the electrons are quantized. So it states both the position and the energy of the electrons. That is, electrons are permitted to have only specific values of energy. The electron only can have specific value of energy. So energy is also not continuous. An electron may change the energy through quantum jumps. So an electron can jump to a higher energy level with absorption of energy. It also can jump to a lower energy level if it's available with emission of energy. And this press to other energy level is called quantum jump. Thus, the Bohr model represents an early attempt to describe electrons in atoms in terms of both position and energy. This Bohr model was eventually found to have some limitations. A resolution was reached with a wave mechanical model. Wave mechanical model. In which the electron is considered to exhibit both wave-like and particle-like characteristics. So it shows both wave-like and particle-like characteristics. With this model, an electron is no longer treated as particles moving in a discrete orbitals, like the Bohr model. Electrons located at discrete orbitals. Rather, position is considered to be the probability of an electron, which is at various locations around the nucleus. In other words, position is described by a probability distribution or electron cloud. So it's described as by a probability distribution. In fact, both these two models are used throughout the materials research and development. The choice depends on which model knows the sample explanation. Okay, that's all content of this video. I hope it's helpful to you. Thank you. Bye bye.